MCP has lately become a buzzword when it comes to AI. Some people are already using it, some are still confused, and others have never heard of it at all. In this video, I want to address that gap. I'll try to explain MCP the way I wish someone had explained it to me. We're going to look at why current AI workflow is broken, how MCP fixes it, and then I'll show you real MCP server I built using .NET to solve my specific pain point. It's gonna be exciting, so grab some coffee and let's dive in. To understand MCP better, we have to start with the pain it solves. When first LLMs came out, our workflow was purely chat-based. You ask for code, you copied it, tried to run it. If it failed, you copied the error, pasted it back, and explained the context all over again. It was a constant loop of switching context between your application and the chat. The problem is that LLM is isolated. It doesn't know about your project structure, your architecture, your dependencies, unless you explicitly provide all of that. We've been acting as a manual bridge between our data and the model. Not only was it inconvenient, it was also a security risk. Copy-pasting source code configuration or some sensitive data into a chat window is risky and really hard to control. This is where the Anthropic team stepped in with the Model Context Protocol, or just MCP, which, as its name implies, provides a context to your model. Think of it like USB port for AI. Instead of you copy-pasting context, MCP gives LLM a standard way to plug into your data. That means that the model can read your project files, understand your dependencies, and even execute commands within clearly defined rules. That makes your interaction with the model much simpler. You can ask it to refactor a specific class without pasting the class itself or explaining the surrounding architecture, because it already knows this context. But MCP goes far beyond just coding. Because MCP is an open standard, you can build your own MCP servers to let the model interact with almost anything, like databases, internal tools, smart home devices, or even your local hard drive. Logically, MCP server is the application which exposes interface that LLM can call to execute specific logic. This also makes LLM behavior more deterministic. An MCP server can perform the logic that a model would struggle to handle reliably due to a limited context window or just non-deterministic reasoning. Consider, for example, if you need to read header data from several multi-gigabyte files. You can't load all the data into a chat without overwhelming the model. Instead, MCP can read only required pieces of those files and pass the relevant information to the LLM for further processing. Security improves as well. The model never gets direct access to your file system or database. It only sees exact data the MCP chooses to expose. As a result, MCP server does more than just provide a context. It effectively isolates the LLM from anything it is not supposed to access. And this isolation improves safety and reliability, reduces overload, and lowers the chance of hallucinations by ensuring the model receives only the limited set of information it actually needs, no more, no less. There are plenty of ready-made MCP tools out there for GitHub or Postgres, but today I want to show you a custom server I built in .NET to solve a very specific problem of mine. As I often work with the content, I have to deal with terabytes of footage. Every time I dump my SD card, I get these generic file names like MVI plus some random numbers. If I want to find, let's say, a clip of sunset over the mountains, I have to open files one by one, and sometimes it takes hours. Thumbnails help a bit, but they are slow, take space, and aren't always practical. So the idea was to let AI scan my media landing folder, look at the images and videos, understand what's inside, and tag and rename them for me automatically. So this is exactly where MCP fits. Let me show you the result first. Here I have Cloud Desktop. I've just copied photos and videos from my SD card into this landing folder. And then I simply ask, hey, I have new media files in my personal folder, please organize them. I'm on macOS. The first thing Cloud does is ask for permission to access that folder, and I approve it. And then MCP Server takes over. A few moments later, the files are processed. So let's check some examples. For example, this one, tablet and coffee. Well, that's my iPad next to a coffee mug. Now let's check this, herbal tea. Okay, it's a green tea B-roll. Nice. Now let's check camera lens. Okay, it's a close-up shot of my Canon lens. And now let's check this typing keyboard. Well, it's a clip of me typing. And this gray mug. And yes, it's a video of a gray mug. As you can see, it's pretty accurate. On the left, you can see the original files with random camera names. And on the right, the same files now tagged and renamed based on their actual content. So now, instead of guessing, I can see what's inside each file just by literally checking the file name. This saves me a huge amount of time when working with photos and videos. Pretty powerful, isn't it? Now let's look at how this is implemented. And let's start with the architecture. On the client side, I'm using Cloud Desktop, which natively supports MCP. Cloud talks to my local .NET app using the protocol. This app stays entirely on my machine. That .NET application is basically my MCP server. It reads the heavy video files, extracts keyframes, and sends them to the LLM for tagging. I'm using Gemini 2.0 Flash to analyze my video keyframes, generate text, and then my application renames the files automatically. This is totally secure because AI never touches my hard drive directly, it only asks my server to do so. Let's quickly look at the code. I am using the C# MCP SDK. The core concept here is tools. A tool is just a function that AI can call. In my case, the main tool is organize footage method. Description attributes tell the LLM exactly what each tool does. The clearer and more precise you are in plain English, the better the model understands when and how to use it. My code scans given folder, finds video files, extracts keyframes using FFmpeg tool, and then sends those frames to Gemini 2.0 Flash for tagging. Gemini Flash is fast and cheap. For my usage, this costs well under $1 per month. I don't bother sharing my video keyframes with a cloud model, but if you prefer, you could swap this out for a local LLM and keep everything fully offline, that's totally possible. Now let's look at the configuration. This is where we tell Cloud how to run our server. Since we're using .NET, we provide full path to the .NET runtime and point it to our project folder. This is also where I define environment variables. Of course, this is just scratching the surface. Because this is .NET, you could extend it to do anything. You could connect it to your Outlook calendar, your SQL database, your smart home devices. MCP turns LLM from simple chatbot to an intelligent system. It reduces the chance of it hallucinating because it has access to real data, and it becomes safer because you control the code execution. If you're curious, I've shared the full source code and Cloud Desktop config on my GitHub, the link is in the description. It's a bit rough, so treat it as a starting point and tailor it to your own setup. If you enjoyed this practical dive into AI engineering, hit the like and subscribe, and I'll see you in the next one. Cheers!